Hey guys, I'm very excited for another episode of Show About Science. This is your host, Nate. And today we are in beautiful Silicon Valley, California. Oh, look over there. It's 23andMe. And of course, you know I have an interview planned. It's going to be an awesome episode, so stay tuned. A little while back, I took a 23andMe test, and now I'm here at the 23andMe headquarters to learn more about my results. So let's go meet our guest, Jhulianna.
I'm Jhulianna Cintron from 23andMe. I'm a senior product specialist. Thank you for having me here.
Okay, so what is 23andMe?
23andMe is a direct-to-consumer genetics company, and we can tell you about your ancestry and about your health.
Why is it 23 and not 24?
Most humans have 23 pairs of chromosomes, so that's what our name is based on.
So what type of DNA do you analyze?
So we analyze DNA that's called autosomal DNA, and you inherit that in equal parts from both your mother and your father, so approximately 50% from each. So those are chromosomes 1 through 22. And then for your maternal haplogroup report, we're looking at your mitochondrial DNA, and for the paternal haplogroup report, we look at your Y chromosome DNA.
Okay, so what are the different things that 23andMe can determine about people?
So in terms of your ancestry, we can give you your ancestry composition results, and that's your genetic similarity to our 31 reference populations. It can give you your maternal haplogroup report, which traces your ancient maternal line. It can give you your paternal haplogroup report, which traces your ancient paternal line. It can tell you about your DNA relatives, so other 23andMe members who share DNA with you based on your result.
Could you tell me about what a haplogroup is?
Yeah, I can tell you what a haplogroup is. So men like you have two haplogroup reports. You have a maternal haplogroup report and a paternal haplogroup report. And what that is a report that tells you about your ancient ancestry. So the maternal haplogroup, we trace it using mitochondrial DNA, which you inherit just from your mom, and it doesn't change over time. So we're able to look at your maternal haplogroup and see the migration patterns that shows that your ancestors went from Africa all the way to the Americas. Okay.
So my group went from, it looks like Tanzania to what looks like the Congo, up across the land bridge into Europe, and then it went across another land bridge into Italy, and then maybe took like a ship a bunch of years later to the US.
Yeah. So that's your maternal haplogroup. And your paternal haplogroup
comes from dad.
It's traced using the Y chromosome, which only boys and men inherit. And so it does the same thing here. It traces your ancient paternal line. So it starts with your dad and goes back to his dad and so forth, back thousands of years ago. Isn't that cool?
Yeah. So how do you get the results?
Okay, so remember that box with the sample kit that you spit into?
Mm-hmm.
Okay, so that had a plastic collection tube where you spit into it, right?
Mm-hmm.
And then you sent that to the laboratory, and they analyzed it and gave you results. So what we're looking at are things called SNPs. Do you know what a SNP is?
What?
It's a single nucleotide polymorphism. And what that is, it's differences in single base pairs that are known to affect your ancestry or your health. And so those base pairs are what's different in humans, and that's what makes you so unique. So what we're doing is we're comparing your DNA to the 31 reference populations that we have and assigning you a percentage based on how similar you are to those 31 reference populations. Does that make sense?
Yes. So what is a reference population?
So a reference population is made up of individuals with known ancestry. And so those are people that have similar DNA, but they're different from other reference populations, which is how we can tell them apart.
What was the big word in the beginning that you said?
The single nucleotide polymorphism.
Yes, what is the single morphotide polymorphism?
So again, those are the single base pairs, the differences between those. So while you can have an AT someplace in your genome, I might have a CG. And so those are the differences in the SNPs. Do you know what a base pair is?
No, what's a base pair?
So a base pair is we're looking at the A's, the C's, the T's, and the G's in your DNA.
Adenine, thymine, cytosine, and guanine.
Good. And so those pair together. And so A always pairs with
T.
and C always pairs with
G.
Great. And so those differences in that
Another way
are the
to tell
SNPs.
it. Another way to tell it is apples are on the tree, and the car gets parked in the garage.
Wow, that's a great way to remember that. Thanks. All right, so let's take a look at your results. So you are 100% European, but we were able to break that down further into 53.5% Northwestern European. So that's broken down even further into 18.7% British and Irish, 2.8% French and German, and then 32% broadly Northwestern European. So that means that we can tell that that part of your DNA is from Northwestern Europe, but we can't pinpoint it specifically to one of these more specific reference populations. And then you have 15.4% Ashkenazi Jewish DNA, and then 13.5% Eastern European DNA, which is, in terms of our reference population, represented by people of Ukraine, Russia, Poland, and Hungary. You also have 3.8% broadly Southern European. So again, we weren't able to pinpoint it specifically to one of those, but it doesn't mean that you don't have that type of DNA. It could be Italian, it could be Iberian, it could be Balkan. So as we get more data, as more people do 23andMe, and we're able to make these reference populations a little bit more specific, hopefully what'll happen to your results is that all of these broadly Southern and Northwestern European, those percentages will get lower, and the more specific ones will get higher.
My question is,
I hope I can answer it.
what do you do with all the spit that we spit in the tube?
So that spit is what we use to analyze, your DNA and give you your results. So we're looking at the white blood cells in your saliva. And then if you elected to discard it at the laboratory, they throw it away. And if you elected to have it biobanked, they keep it just in case there's a new report coming that we need more saliva for, or in case the first time that we run your DNA, there's not enough, we'll rerun it again with the other saliva in the tube.
I kept mine biobanked.
Okay.
Thank you for being on the show.
Thank you for having me. I had a great time.
There you have it, folks. The show about science is complete. Dad, you can shut the recording off.
Have you taken a look at that report?
No, I haven't.
So these are survey questions that your DNA relatives have taken.
28 less likely to have lived near a farm when they were young. 67 less likely to make New Year's
resolutions.
45 less likely to be a superstar.
Super taster.
A super taster.
It's okay, I thought it said superstar too when I first saw it.
11 less likely to have sweaty feet. 11 and less likely to be able to wiggle their ears. I can't do that. 10% less likely to be able to sing back a note they have just heard.
We tried that. It didn't sound good.
Try it. Let's try it again. For the newest episodes of the show about science, download the Pin app or go to pinna.fm/promo.